I very often go to high schools and elementary schools. I make science shows there, mostly in physics. And whenever it comes to chemistry, students are always very ashamed that they don't like chemistry. Do you like chemistry? Okay, good. You're supposed to like it. So I decided yesterday that I would bring some funny chemistry experiments to you. Then in the morning, I realized where I'm coming to. Good job. So first of all, what is here in this flask? Okay, there were different guesses, as I heard. There was one Palinka. Okay, we will get back to alcohol later.
Let's put this in your pocket.
I have my.
Okay.
I have mine. Okay. Okay. What else can it be? Water or vodka. Yeah, it's another option. It's very hard to tell by the looks, and that's why I brought this little comic strip for you. I'm sure many of you have seen this because it got tens of thousands of shares on Facebook recently. If you haven't seen it yet, or if you cannot read it from behind, it's just the regular joke setup. Two men walk into a bar. One says to the bartender that I'm a chemist, so I will just have some H2O. Very funny. The other guy says, okay, I will have some H2O too. Then they get the whatever they ordered. One drinks it, satisfies his thirst. The other one dies. Okay, what happens here? What is this here? It's a circle. Very good. What else can it be? What can it be to a chemist? It can be an oxygen atom, right? If I add one more O here, what is this? Two circles, two oxygen atoms. We have to bind them together, right? We can do it either by two bonds, then it's an oxygen molecule, right? What you can find all around us. Or if you connect them with a single bond, it is a peroxide. And we can create the most simple peroxide ever. You just have to add some hydrogen to it. Two hydrogens, and you get hydrogen peroxide. Why is it so dangerous? What's the problem with hydrogen peroxide? Why cannot I drink it? Yeah, you can drink it once, true, but hydrogen peroxide is a very unstable chemical, okay? It has a very high oxidizing capacity, therefore it's very dangerous for us. Not only for us, but other living organisms as well. Therefore, organisms try to defend themselves against hydrogen peroxide. I have some little creatures here. It looks very disgusting. Actually, it's just baking yeast, nothing special. Yeasts are fungi, you know, small funguses. They produce an enzyme called catalase, which can break up hydrogen peroxide into hydrogen and, into water and oxygen. So let's see what happens if we mix yeast and hydrogen peroxide together. If I just did it this way, you wouldn't see anything. So we have to make a little alteration to this experiment by adding some detergent to it. Okay, it's just simple dish detergent. I just bought it at Rossmann, so you can do it at home. You can get hydrogen peroxide in the pharmacy, so you can just carry out this experiment at home easily. Oh, and I would also need the cap for this. Oh, this one fits for sure. So, when I added this detergent to it, the forming oxygen will create a very nice foam for us, hopefully. So let's see what happens. I add the yeast to it, which produces a lot of catalase enzyme. Therefore, a lot of oxygen produced. And then you can have a little fountain. Sometimes it works much better. Sometimes it shoots all the way up to the ceiling. Luckily, it didn't happen here. You can try it at home. Maybe it will work for you. So what you have here is pure oxygen and water. So it's very safe. Now you can touch it. You could even drink it, but I don't suggest you drinking it because you would get probably some diarrhea from the detergent itself. Okay, let's see what else I have here. When I first asked what I had in this flask, some of you said it was palinka, right? Okay, so let's talk about alcohol. Alcohol is very good for you. When it comes to experiments, I have to add this little remark to it. For this experiment, I will use pure alcohol. Actually, I will do it at the end. Okay, actually, I'm moving. So I will use denatured alcohol. Let's say it's pure alcohol. You can use ethanol for the following experiment just as well. Let's put some alcohol in just a regular plastic bottle, okay? Little alcohol is enough. Oh, and this is an experiment you are not supposed to do at home, okay? Because it's dangerous. Only with parental supervision, okay? So never pour pure alcohol in a plastic bottle, okay? Promise? Yes? Okay. Never drill a hole of 6 millimeters in diameter onto the Coke cap, okay? Never screw it on the bottle, and never shake this bottle, okay? What happens with the alcohol inside? What happens with it? Yeah, shake it. What happens to the alcohol? It evaporates, right? It evaporates very, very rapidly. Soon, alcohol vapor fills this bottle here. And as we know, alcohol can be ignited very easily. So when I ignite it through this little hole here, you can just make... So I can never decide whether Americans are allies or enemies.
Justin Bieber again, I promise.
This is also Justin Bieber, okay? And okay, so it's that simple to make rocket science. What happened here, alcohol got ignited, the air inside heated up immediately, and as hot air expands, sorry for the microphone, it just shot out through that little vent we put on the cap here, and that's what caused this rocket move forward. It was simple Newton's third law, so it's not rocket science. Actually, it is rocket science, but it's not very complicated. But if we have alcohol, let's do some other tricks with it. I just pour the alcohol over my hand, over this sponge here. I just soak it in a lot of alcohol. Actually, now I would probably need that towel if you have it. It happens sometimes. That's why you are not supposed to do it at home over the carpet. Because we will ignite this sponge here. Where is my lunchbox? What color will it have? What's the color of alcohol when it's burning? Blue, right, but it won't be blue because of all kind of stuff in this sponge. So anyway, you can see the flame, right? It's visible from everywhere. Okay, what happens when I spin it? Will there be anything special? No. Nothing special. A spinning flame is just a spinning flame. Nothing special happens here. But when I put it out, and I put it in a garbage can, never ever set fire in a garbage can at home, okay? You can do it at school, but not at home. Let's see what happens when I spin it now. Nothing happens. You can just make a little fire tornado, which would be very, very dangerous in nature. Luckily, you can just tame it at home and just watch it when you have nothing interesting on TV or on the internet and you are bored with Justin Bieber videos. And it's a nice substitute for that. That's next. Okay, what happens here? Air flows toward the flame, okay? But as we have this mesh here, air just cannot go directly to the flame. It is a bit diverted by this wire mesh here. That's why the air gets to the flame a bit off-center, and that causes the spinning motion here. Okay, I put it out because we saw it already. And if we are talking about spinning motions, let's come back to physics. No, it's okay.
I'm getting it out of here before you burn it up.
I think. Okay, I will manage. Microphone again. I just put it here. Is it good? Good. Yeah, talking about spinning things. I try to spin this huge coin, which I have here. Okay, and let's see what happens. It's pretty much the same when you just spin a 100 forint coin on the table. The only difference is this coin is much heavier and much bigger. Let's see what happens when I spin it over a very flat, very smooth surface. It spins like a regular coin, right? The only problem is that it doesn't want to stop. Why is that? Any ideas? Should we switch to Hungarian? Okay, it's still spinning. What can be the science behind it? Who has any idea? Okay, I see it's funny. Okay. Eventually, if I did it right, it could spin for like 5 minutes. It won't spin for that long now, but if I was talented enough, I could do it. Now it stopped. There's no magnet underneath. That's the most common question. I don't know why people think there would be a magnet under this table, because if there was a magnet, this is an iron disc, so it would just stick to it and wouldn't move. When I spin this coin, when I spin this large disc here, it has potential energy and kinetic energy. You are familiar with these expressions? Potential energy, helyzeti energia, kinetic energy, mozgási energia. Okay, now you all know what these words are in Hungarian, so you just added it to your vocabulary. It's very useful, right? Jó reggelt, helyzeti energia. It's very simple. Okay, so now it has high potential and high kinetic energy, right? When it leans a bit, it gains which energy? No, actually, it's the other one. It gains some kinetic energy from potential energy, okay? And these two types of energies are converting into each other continuously. That's why it keeps moving practically forever. Unfortunately, we have some friction here, and that's why it will stop eventually at one point. Okay, I see it wasn't your favorite thing, so I just try something else. Let's fire up this little science demonstration here. It's a regular gas torch. You can get it at OB for low cost.
Don't point that at me, all right? No?
I'm not. And one more thing we will need for this experiment is a metal tube, okay? It's a tube, you can look through it. So let's heat the inside of this tube. Does anything happen? No, but it will soon burn my hand. Metals are very good conductors for heat. And when I hold this tube vertically, it produces a sound, right? What can happen here? Who has any idea what's wrong with this tube? Oops. Okay, this little wire mesh gave me away, I'm afraid. Okay, I cannot hold it now. But... Anyway, I put this wire mesh somewhere here in the tube. Yeah. To the hot part. Yeah, you cannot tell I worked in a lab for 5 years. Yeah, right. So I put this wire mesh in this tube here. When I heated it up, it heated up air, okay? As we saw at the rocket experiment, hot air expands, so it tries to escape at both ends of this tube. When air comes out of the tube, there is low pressure inside, okay? There's little air inside, so there will be low pressure. What comes next? Air wants to go back to the low pressure areas. And this wire mesh was put somewhere here, so it was pretty much asymmetric, okay? So velocities of flowing air in both directions, that's what caused a little turbulence inside, and that's what caused this whole tube to resonate, and that's what produced this sound. So it's very simple. You can do it at home. You can just use the wire mesh from the stove. That's where I got mine from. Your parents would love it, I'm sure. Thank you very much. I speak some Hungarian in case you haven't noticed, but I take it as a compliment. For non-Hungarian speakers, okay, I don't translate it. Okay, you want to see an experiment with fireballs? Should we make a fireball? But for that, I would need a volunteer. Any volunteers, or should I pick someone?
You almost killed me before.
No, I wouldn't. Okay, let's skip the fireball first. I have another experiment. I have this nice t-shirt here. It was washed several hundreds of times, probably. So it's not a problem if I get it dirty a bit. At the Palace of Miracles, we have a toy store. And kids love to buy scientific toys there. Especially, they love this magic ink here. Sometimes I am at the store, and sometimes I tell them it's not magic at all. They look at me not too nicely, but anyway. So this ink is very good for kids because they can just go to their parents or to anyone with a bright color t-shirt or pullover. They can just squirt this ink on shirts. And soon, could you come here? And soon it turns out, that this ink disappears. Okay?
Okay.
Are we good?
40,000 I want to.
Yeah, all right. Luckily, luckily it's a magic ink. If you put it on anywhere, it will disappear in no time. However, parents come to me all the time and ask me, does it disappear from any kind of clothes? And I say, well, it's sort of a tricky question, because it doesn't disappear from anywhere. It remained on your shirt, it remained on your tie, it remained even on my old worn t-shirt, it's still on your pullover. And there comes science. I tell them it's still there. But this is an acid-base indicator, okay? It is highly alkaline solution, but when the carbon dioxide from air dilutes into it, it forms carbonic acid. It will push the pH down toward the acid area, and there will be the color change. This indicator has two colors. When it's very alkaline, above 10 pH approximately, it's dark blue. Below that, it's transparent. Okay? I will prove this to you. If you have some sodium hydroxide, never put it in a Coke can, okay, or Coke bottle. I'm showing you how not to handle chemicals, okay? Although I put this little skull on it. But if I pour it over my t-shirt again, you can see the ink is still there. So I'm not pouring it on you, I promise. Luckily, you can just rinse it out with water. So by the time next time you wash your shirt, by the time next time you wash his shirt, it will go away and it won't damage any kind of fabric. So you can just buy it. You can try it. It's really fun until you can escape from your parents, not for your age, but probably your brothers or sisters if you have smaller brothers or sisters. Okay, so that's about magic ink. I don't know how I am with time. What time is it? Mennyi az idő? Okay, I have 5 more minutes. Good. So let's finish with this fireball experiment. And for that, I would need a volunteer who can move fairly easy. Could you come and help me, please? Applause, applause, people. Great. Okay, István will be my big help here. I have this powder. Just make some clearance here. There you go. I picked someone with glasses, okay, so there won't be a problem. Okay, ready, set. Chemist students, right? Okay, that was the rehearsal. Let's do it again. Okay, ready, set, go. And nothing happens, right? So what can be the problem? You need 3 criteria for producing a flame. Which are these 3 things? Yes, fuel, heat, and oxygen. Which one of these are lacking here? Okay, we have highly combustible material here, so we have fuel for sure. Oh, maybe it's the heat. Az a tuti. I removed the alcohol, okay? Here you go. At the tip of the flame, Here we have, no, I don't put my finger in front of it. I'm not that stupid. I am stupid, but not that much. Okay. Here at the tip of the flame, we can produce 750 Celsius degrees. Okay? So it's a high temperature. Okay, it's not the heat either. We need oxygen. Don't we have oxygen around us? Yeah, we have plenty of oxygen. Unfortunately, this powder is so fine that they settle down in this mount here, and no oxygen, no air can surround the little dust particles. So we have to spread them in order to get enough oxygen. And for that, I would need your hand. Nem vagy aszmás, ugye?
Aszmás vagyok és allergiás.
Igen? Jó, hát bocsánat. Hamar el fog égni.
Ez égés lesz, úgy érzem.
Okay, now throw that powder in the flame, okay? All of it. Okay, thank you very much. Applause, people. So these were the experiments I wanted to show you. I hope you don't mind your shirt. It will dry completely. Probably it has dried already.
You can talk to her.
Okay. Sorry for his shirt. So thank you very much for your attention. And if you want to see more, or if you want to see more physics experiments, just come to the Palace of Miracles and feel free to enjoy your time there. Thank you.